Have you ever stopped to think about the secrets hidden within those steel giants you see roaring down the highway? Today, we're going to tear them down piece by piece, because this is the only video you'll ever need to understand everything behind these trucks. From axles that fly over the asphalt to engines that shake the very ground they stand on, we aren't holding anything back. So get comfortable, because things are about to get interesting from the very first second. Why do some axles stay off the ground? You've probably seen it more than once. A massive rig cruising down the road with one or two axles completely lifted in the air. Is it a mechanical failure? A distracted driver? Not at all. It's exactly what's supposed to happen, and there's a brilliant piece of logic behind it. And axles are the pillars that support a truck's entire weight. Essentially, they connect two wheels and transfer the engine's power to the ground. But not all axles are created equal. On a typical semi-trailer, you'll find three main types. Steer axles, located at the front, allow the driver to maneuver. Drive axles, situated at the rear of the tractor, are what actually propel the truck using the engine's full power. And then there are the lift axles, those extra companions that only join the party when they're actually needed. So, when are they needed? When the truck is loaded to the brim. Under a full load, these axles are lowered to distribute the weight evenly across all wheels, improving grip on the asphalt in tough conditions like rain, snow, or ice. It also spreads the pressure on the pavement, reducing road damage. And if that weren't enough, it allows the driver to stay within the legal per-axle weight limits required by authorities in every jurisdiction. But when the truck is empty or carrying a light load, why deal with the extra wear and friction of those additional wheels? Raising them reduces rolling resistance and improves fuel economy. It also extends the life of the tires and the axles themselves, preventing them from racking up unnecessary miles. The system works through the truck's air suspension. With the push of a button in the cab, the driver inflates airbags that lift the axle with pinpoint precision. When deactivated, the axle returns to its working position. Simple, elegant, and incredibly effective. Fun fact, on some Volvo models, the tandem axle lift function can activate automatically based on the load detected by the system, all without the driver ever having to lift a finger. When it comes to safety, the advantage is twofold. With the axle down and more rubber meeting the road, braking power increases significantly, resulting in shorter stopping distances. Furthermore, better distributed weight provides greater stability in sharp turns, reducing the risk of a rollover. Lift axles are, without a doubt, one of those inventions that make the road safer for everyone. Why do trucks run on diesel instead of gasoline? This seems like a simple question, but the answer goes much deeper than you might imagine. In the early 20th century, trucks actually did run on gasoline. So, what changed? The key is torque. Torque is that rotational force that allows an engine to move massive loads from a dead stop, climb steep grades, and maintain steady speeds while hauling tons of freight. To generate more torque, an engine needs pistons with a longer stroke, and a longer stroke means more compression inside the cylinder. This is where diesel has a brutal advantage. It can handle much higher compression levels than gasoline without detonating prematurely. When gasoline is subjected to those pressures, it explodes uncontrollably before the piston reaches the correct position, a phenomenon known as engine knock or pinging. Diesel, on the other hand, is designed to ignite precisely through compression, making it the ideal fuel for high workload engines. Additionally, diesel has a higher energy density than gasoline, meaning it stores more energy per gallon. That translates to a diesel truck needing less fuel to do the same amount of work. But see, look at the real numbers. Diesel engines outperform gasoline engines in efficiency by 20% to 35%. For a trucker covering about 75,000 miles a year, that can mean a difference of up to $44,000 annually in fuel alone. And for a fleet of 10 trucks, the savings are staggering. But efficiency isn't everything. Diesel engines are built with more robust components to withstand the extreme pressures of the compression cycle, which results in exceptional durability. It's not uncommon to see diesel trucks surpassing the million-mile mark without major issues. That means less time in the shop, fewer replacement parts, and more time on the road making money. As for the electric future, electrification sounds perfect on paper. but the batteries required to give a loaded truck sufficient range weigh several tons, which slashes the payload capacity. Charging them takes hours, not minutes, and replacing them when performance drops comes at an astronomical cost. For now, diesel remains the undisputed king of heavy transport. If you're finding this video helpful, hit that like button right now. It helps the channel immensely and keeps us bringing you detailed content like this every week. Why do European trucks have more powerful engines? If you've ever compared the specs of a European truck to an American one, you might have noticed something striking. Brands like Volvo or Scania offer engines with up to 770 horsepower and 2,700 pound-feet of torque, while in the United States, the ceiling usually hovers around 605 horsepower and 2,050 pound-feet. Why the gap, especially when American trucks look so much larger? The answer rests on three pillars: weight limits, geography, and culture. In the United States, the federal limit for a semi-trailer is 80,000 pounds. With that load, a 500 horsepower engine with 1,850 pound-feet of torque gets the job done perfectly on highways that are, for the most part, flat and wide. There's no need for more power because the country's geography doesn't demand it on major routes. In Europe, the situation is completely different. Sweden allows trucks up to nearly 200,000 pounds on certain stretches. Finland authorizes over 160,000 pounds, with the potential to reach 200,000. And that's not even counting the mountain roads of the Alps or the Pyrenees, with steep grades and altitude changes of several hundred feet. When you have to haul 60 or 70 tons up a mountain pass, a 16-liter engine with 2,600 pound-feet isn't a luxury. It's an operational necessity for survival. An interesting fact about manufacturers: while it may seem like every brand has its own independent engine, the reality is more tangled. Detroit Diesel is owned by the Daimler Group, which also owns Mercedes-Benz. The Traton Group controls both MAN and Scania, and they are developing shared engine platforms. Volvo shares technology with Mack and Renault. In practice, these engines are more closely related than they appear. And then there's a factor that can't be ignored: pride and identity. In Europe, many owner-operators customize their trucks with unique paint jobs, chrome, and modifications. Driving a Scania 5.8 isn't just a technical choice, it's a style statement. The unmistakable rumble of that 8-cylinder V engine is a cult favorite among enthusiasts. And in a market facing a driver shortage, having the most impressive truck on the highway is also a powerful recruitment tool. The long wheelbase dilemma. In the world of American trucking, one of the most common debates is whether it's worth switching to a long wheelbase truck. The wheelbase, the distance measured from the center of the front axle to the midpoint between the rear axles, can vary dramatically. And that difference changes everything. With the arrival of increasingly longer trailers, tractors had to evolve. Starting in the 1970s, regulations began focusing only on the length of the trailer, not the entire combination, giving manufacturers the freedom to lengthen the tractors. The result is the long wheelbase trucks we see today, which can reach up to 300 inches between the axles. The advantages are obvious: more comfort for the driver thanks to a longer cab with better living space, a smoother and more stable ride due to the increased distance between axles, and the ability to haul flatbed loads up to 70 feet without worrying about rear overhang or special permits. But it comes with trade-offs. The weight is higher because the reinforced double chassis adds pounds to the rig. Fuel consumption is higher, and maneuverability takes a hit. In loading zones, tight ramps, and narrow streets, maneuvering a truck with a 300-inch wheelbase can quickly become a nightmare. There's also a specific problem well known among truckers: curb climbing. When the front wheels go over a steep curb, the fuel tanks located between the axles are exposed to that sharp point. In a short wheelbase truck, by the time the tanks reach that spot, the rear wheels have already climbed the curb, lifting the chassis. In a long truck, that natural protection disappears. According to the most experienced professionals, the optimal distance is between 260 and 280 inches. That range maintains the maneuverability needed for any scenario, preserves cargo capacity, and provides the extra comfort that makes long hauls more bearable. Plus, the higher resale value of these trucks partially offsets the increased fuel costs. Subscribe to the channel if you haven't already. We post content like this regularly, And you won't want to miss our upcoming videos on the world of transportation. The automatic transmission revolution. Just 15 years ago, learning to drive a semi-truck meant mastering double clutching, gear synchronization, and the ability to manage between 10 and 18 speeds with surgical skill. Today, 90% of new trucks sold in North America feature automatic transmissions. The shift has been radical and lightning fast. Why so many gears? Because a truck engine needs to operate within its optimal RPM range at all times to stay efficient. Starting from a dead stop with an 80,000-pound load requires a very short gear ratio. Cruising at 75 miles per hour on the highway requires exactly the opposite. Without a wide range of gears, either moving the load would be impossible or the top speed would be ridiculous. The first automatic transmission for a semi was introduced by Eaton in 1950, but it was primitive and unreliable. In the 90s, automated manual transmissions, AMTs, arrived, combining the economy of a manual with the ease of an automatic. Essentially, all a manual gearbox managed by a computer. That was the turning point. The advantages are manifold. The driver can focus entirely on the road without the distraction of managing gears, which reduces fatigue and improves safety. The computer shifts with a precision that's impossible to replicate manually, optimizing fuel consumption with every mile. On hill starts, the electronics manage the torque so that it eliminates the risk of rolling backward or burning out the clutch. Maintenance is also simplified. With no clutch for the driver to wear down, service intervals are extended, and the learning curve for new drivers is dramatically shortened, something vital in a sector facing a chronic shortage of professionals. The downsides? The initial cost is slightly higher. Although the gap has closed so much that several manufacturers now offer automatics as standard equipment. Electronic complexity can make repairs difficult in under-equipped shops. And some veteran drivers simply miss that feeling of total control that came with a manual box. The future points toward electric vehicles, which by nature don't need a gearbox. The electric motor delivers maximum torque instantly from 0 RPM. Although electric trucks are still rare on the roads due to range and charging limitations, they represent the inevitable horizon the industry is moving toward. To finish up, here are some facts that surprise even industry professionals. A loaded truck tire can support up to 10,000 pounds. And proper inflation is critical. A tire with just 20% less pressure can increase fuel consumption by 2% and cut its lifespan in half. The diesel engine was patented by Rudolf Diesel in 1892. Its inventor died under mysterious circumstances in 1913. Vanishing during a boat crossing of the English Channel, his body was never found. Long-haul trucks in the U.S. travel an average of over 100,000 miles a year. To put that in perspective, that's equivalent to circling the Earth 4 times. The engine brake or compression brake, known as the Jake brake, after the Jacobs brand that popularized it, works by turning the engine into an air compressor to slow the vehicle down without using the service brakes. It's so loud that many cities have specific signs banning its use in residential areas. In China, some of the heaviest trucks in the world operate, the so-called road trains, which can pull 4 or 5 trailers linked together with total weights exceeding 300 tons. They are literally trains without tracks. And with that, we've reached the end of this journey through the hidden universe of trucks. We've unraveled the mystery of flying axles, understood why diesel dominates the world of heavy transport, seen why Europe needs 770 horsepower engines, explored the key decisions behind long wheelbase trucks, and witnessed how automatic transmissions have redefined the profession. Behind every truck that passes you on the highway, there are decades of engineering, economic decisions, regulations, and culture that have shaped it into what it is today. The next time you see one of these giants, you'll know exactly what's happening under the hood, under the chassis, and at every axle. If you found this video interesting, give it a like and share it with someone who's passionate about trucks and engines. And if you want to keep learning about the world of transport, engines, and everything that moves the world, subscribe to the channel. We'll see you in the next video.